Okay, in this video, we're just going to go through a challenging question involving your understanding of groups. So we have a group G with an order less than 10. So there are less than 10 elements. And in 3 of its elements, A, B, and C have the following properties. So we've got A combined with A equals B, A cubed equals C, and finally A combined with B combined with C equals to A. And we need to establish what is the order of G and explain our reasoning. So we know the order is less than 10. Okay, so it's a number from 3 up to 9 because we've got 3 elements here. Assuming these are all distinct elements, okay, the order must be a minimum of 3, potentially up until and including 9. Now let's look at 3 properties we are given. A combined with A equals B. Now that's maybe not the most useful bit of information yet. And same with the A cubed equals C. There's nothing I can really infer from that. However, the last bit here, this is quite helpful because of the fact that we have an A on this side and an A on that side. Because what this is saying is when you take A and combine it with BC, the result should be A. In other words, A has not changed. So therefore, what we can establish from that, since ABC is equal to A, then BC must be equal to the identity E. Okay, it's the only way that's going to be possible. So we now have an expression for the identity element. Now, what else could we do with this BC is equal to E? Where BC is equal to E, the bits of information we haven't used yet is the fact that B is equal to A squared. So I'm going to put that in. And then the C is equal to A cubed. So I'm going to put that in as well. Okay, and that should be equal to E. Now let's simplify. We get A to the power of 5 is equal to E. So what can we establish from that? A potentially common incorrect answer is to immediately say that therefore the order of A must be 5, because A to the power of 5 gives us our identity. However, all you can say at this point is that, without further explanation, is that the order of A must be a factor of 5. Okay, so therefore the order of A must be a factor of 5. The reason being is when we're talking about order, okay, the order of A would be where A to the power of n is equal to E. Then we would call n the order, providing n is the smallest positive integer that achieves that. Now, if A to the power of 5 is equal to E, what you'll find is that any factor of 5 could also potentially work as the power. Okay, so we do still need to explain that. So the factors of 5 are 5 or 1. So therefore, the possible orders of A are 1 or 5. Now, 1's a special order because that's reserved for the identity. So let's consider that case. In the case where the order of A is equal to 1, then A is the identity. Now, there's nothing that explicitly in the question says A is not the identity. However, if A combined with A is equal to B, well, that wouldn't make sense if A is the identity. Okay, because if you have A combined with A and A is the identity, then the result should be A. So therefore, we can establish that A is not the identity. So in the case where the order of A is 1, then A is the identity and A squared should be equal to A. However, A squared is equal to B. So the order of A cannot be equal to 1 since A cannot be the identity. So what we can establish from that is therefore the order of A must be equal to 5. So we've now figured out the order of an element. Remember, the order of the element must be a factor of the group order. So therefore the group order must be a multiple of 5. Now the group order is less than 10 and the only multiples of 5 less than 10 but also the same as or greater than 3, which is how many elements we know are definitely in there, okay, would be 5 itself. So therefore the group order must also be 5. Okay, so I'm just going to write that out. Therefore, 5 must be a factor of our group order, and the only multiple of 5 less than 10 and the same as or greater than 3 is 5. So the order of G is equal to 5.